Hello guys, welcome back. In this video I'm gonna show you I'm gonna go over the other approach of listing subsets. In the previous video we've uh, we've solved this problem using uh, breadth search, but for this one I'm gonna show you how to solve it in depth search. So just to remind us, and for the breadth search, we go level by level, right? But for depth search, we probably want to go deep down to the uh, leaf node, right? Using recursion. And here is the visualization of our algorithm, right? Same as breadth search, we also start with a empty subset, right? The initial subset. The idea of um, depth search. The idea behind uh, this problem is to to maintain two variables. First one is the current path, and also the space, right? The space. So for example, initially we start with a subset which has no elements, right? So we will start build up from this subset, right? And yeah, we start with an empty subset. We push it to our result array, right? Result, for example, result array. We start result arrays. The first one is empty, right? So after push the result array, we start to build up from here using recursion. So uh, the current part is here, and the other variable we want to keep track of is the space, the current space. So for empty subset, we have initially we start with all the numbers from the input, right? We start with space of 135, right? So the next next choice of our path, right? We probably want to take one out of the space, put it in the our current path, right? So for example, in this case, we take one out from the space, put it in the current path, right? this one, it should be in order 153, right? For this one, we take 5 from the space, put it in the current path, right? So what it laps is everything on the right, right? We don't want to take once, and we don't want to take one again. What we care is everything on the right, which is 3, right? And another options is 3, which is the last element in the space. There's nothing left on its right, so we end up with empty space. So here is 3 new paths, 3 new subsets, right? That we want to add to the result, right? But actually, when actually we're doing depth first search, but not breadth first search. So probably the order of calling functions uh, will be, we start from here, we go here, and from here we want to recursively call the function, right? We could go this way, we go down the tree, but not go this way. So let's go to the example. We take one out from the space, right? Take one out from the space, put it in the path. That's the space is now left with 5 and 3. Okay. So we push the current path to the result as a new subset, right? So for the next function call, we will take the first one out of the space, put it in the current path, which is 1, 5, and we left with 3. So we have another subset, which is 1, 5, and there's still one left in the space, so we can take it out, push it in the current path, right? So we have 1, 5, 3, and the space is now empty. We have nothing to, so we end our recursion here. So after ending here, we probably come back to the previous goal. Come back to the previous goal, right? So we are here, and the only choice we have here is 3, right? And we've done it here, so we're done with this goal also. Come back to the previous one. Here we have 2 choice, 5 and 3. We've done the 5 here, right? We've done the choice with 5 here. So the next choice is 3. So we go with 3. We take out 3 from the space, push in the current part 1 3. Our space left with empty because we don't care about we don't care about the left of 3. We care about what's on the right. So we left with empty here. So simply add 1 3 to our result, and we're done with this. Our space is empty now. We come back, and here we've done with 2 choices, right? So we're done with 2 choices. Come back to the previous score. Here we've done the first one, right? The first choice in the space. We take the second choice, so we go down the recursion, go down 3 5. We take 5 out of the space, put it in the current part. We have new subset, which is 5, right? Our space is left with 3, which is the only one on the right, 5, right? So we have one choice here. We take 3 out of the space, put it in current part. We have new subset, which is 5 3, right? So we out of choice, come back, right? If we're done with the only choice, which is 3, we come back. And here we've done with 1 and 5. Now it's turn of 3. We take 3 from the space, put it in the current path. We have 3 as a new subset. Our space is empty now, so we come back, and we've done with all 3 choices of the first call. So we return. So I think that's pretty detailed explanation that I can give you. So let's code it out to see how it works. So for this one, I'm going to use a class, right? Because I want to store the variable structure. I want to store the result, right? Let's say O. You can name it whatever you want. O here is this one, the result, right? We want to keep it at instant level, so we can you can use it in method to add more subset to the path, right? So we start with function, let's say 5 subset, 5 distinct subsets. We need an input of number, right? We need input of number, so probably the 2 state that we want to maintain between recursive calls here is the space, sorry, the current path, right? The current path and our space, which is what is available to choose from, right? So probably I will call DFS here. We need to keep up. Let's say DFS. DFS let's mark as a internal method. So DFS will take in the path, the current path, right? And also the space. So the path initially is empty, right? The path initially is empty already. The path here is a subset, right? Current subset. And the space initially is the inputs, right? We have all the numbers in input to start with. So for every step, you can see we want to store the current path, right, in the result arrays as a subset, right? So I will push the current space, which is path. Sorry, it's array, so I will push it in, put the path in. So after I push this one in, I want to run to all the everything in the space, right? I will want everything in the space at I equal to 0. I select space length I plus plus, right? So space, right? So for each here, for each item in the space is a choice that we want to make, right? And we will recursively call the DFS and passing what, right? We want to have new state in the next call. We want to update the state in the next call. The path will be one choice from the space, right? The path will be one choice from the space, and the new path with the new subset in one choice for the post be pushed in the current path, right? So I will spread it out so that we have a new array for the next call. We spread the path, save the current choice, which is space. But it's one choice, right? So we have the second one is the space, which is whatever on the right of our choice. So for example, we choose one here and take whatever on the right side of one. So our space I will use here is this. I'm gonna slice out the space slice. I want to slide here the start index, right? I want to take all the way from the I+1 index. The current index is I, so everything on the right is I+1. So after these operations, we have everything is stored in the O. We just return this all. I think that's pretty much it. Let's run it. Let's run the test. Oops, forgot. What's wrong here? So it can be not. So the result of return when we use DFS search may be different from DFS search, breadth search. And here I'm using the same inputs as above. So I think from what we have here, probably copy down over here. Hopefully we have one more passing test. Alright, so it's a problem of ordering. So for this guy, for 1 and 3, right? 1 and 3, we go deep this way, so it 1 and 1 and 3 and 3. Hopefully we have 2 passing tests now. Okay, so that's it for the depth of search of distinct subsets problem. So thanks for watching. See you in the next video.